Hello, I'm Donald Noble from the University of Edinburgh. In this video, I will explain how the DTOceanPlus project is helping to address the sector need for holistic design tools for ocean energy. There is this sector need for holistic design tools to consider the many varied facets of ocean energy. For example, hydrodynamic interactions between arrays, electrical architecture, project economics, environmental aspects, etc. Other design tools for ocean energy are either proprietary and/or may only address one or two specific functionalities. The DTOceanPlus builds on the original DTOcean code, developing a second-generation integrated suite of design tools for ocean energy. This has both new and improved tools with additional features and functionalities, and we have performed further testing and validation within the project. The tools will be freely available to use and to extend under an open source license, part of an ongoing improvement process. The DTOceanPlus tools are for wave and tidal stream technologies, which can be either fixed or floating devices. And DTOceanPlus also now considers different levels of technology maturity, from early stage concepts to commercial feasibility and design. The tools can be run at different levels of complexity, from low complexity mode with fewer inputs, simple data and quicker analysis, through to high complexity with more complex data requirements, longer computational times, but more accurate results. The tools can be run as an integrated suite or individually in standalone mode. They are accessed via a web browser interface, which allow for future development into a cloud-based software as a service. DTOceanPlus is a suite of 15 design tools, which can be run independently in standalone mode or as a more powerful integrated suite. There are 7 deployment design tools and 4 assessment tools to support optimized deployment and evaluate projects, and I'll cover these in more detail next. There is a brand new StageGate tool to assist both developers and funders measure, assess and guide technology development through the use of metrics and evaluation areas linked to the IEA OES. Another brand new tool for structured innovation uses integrated QFD, TRIZ and FMEA methodologies to provide a more structured approach to innovation in concept creation, selection and design. These tools are supported by a new main module and data management tools, including catalogues and a digital representation of ocean energy technologies. We'll have separate videos covering some of these other tools, but now I'll go into the deployment assessment in more detail. So the 7 deployment design tools can be seen on the left-hand side there, with a summary of their functionalities on the right. These are run in order, starting with the site and machine characterization, which are new tools to assist with the data from the deployment site, including metocean, geotechnical and environmental conditions, plus the properties of the machine prime mover. Then we have the energy chain, from hydrodynamic capture performance and array interactions in energy capture, a new tool to consider the energy transformation through the power takeoff and control systems, and finally the energy delivery tool considering the energy delivered to shore via the array cables and substations. In the station keeping module, you can design moorings and foundations to keep the device on station, and you can plan logistical and marine operations relating to the installation, operation and maintenance, and also decommissioning. These deployment design tools give the main outputs of an optimized array layout and configurations, design of the subsystems, a bill of materials for the components used, and much more. The 4 assessment tools can then be used, which take the results from the deployment tools and can evaluate the project in terms of the energy performance at each step in the System Performance and Energy Yield tool. They can evaluate the reliability, availability, maintainability and survivability of both components and the whole project. You can assess the lifetime cost of projects from an economic perspective, and importantly, evaluate the environmental and social impacts of the project. This gives the main results of a set of assessment benchmarks. The DTOceanPlus tools can be split into three main areas: design, assess, and innovate. For design, the user can use the deployment design tools to assist with optimized design of projects of individual devices or arrays. They can assess the performance of these projects in the assessment tools, as I've just covered, and also assess the status of technology development with the StageGate tool. This tool can also be used to guide the best complexity level to use the individual design tools at, as shown on the diagram. Finally, the tools can be used for innovating both new and improved designs in the Structured Innovation tool. The DTOceanPlus project has taken the DTOcean tools to the next step in an ongoing development process, adding new features and functionalities as I just summarised and will be covered in other videos. The tools are now fully documented in an easy-to-navigate online format, as shown on the right. These have tutorials giving step-by-step instructions for new users, a set of how-to guides on achieving specific outcomes when using the tools, an explanation of features, background and theory, explaining the process behind the calculations. Plus, they have a reference section covering the API and code functions to facilitate future development of the tools. Within the project, we have performed additional testing and validation, including by industrial partners using their real projects. So just to recap, the goal of the DTOceanPlus project was to further develop the original DTOcean tools to provide much expanded functionalities. It is now multi-platform. The tools have both standalone and integrated modes. There are new and improved design and assessment modules, plus innovation and development methods. There is also a standard digital representation for ocean energy projects. The tools have been demonstrated with the real projects of industrial partners, equivalent to a technology readiness level of 6, although this is not yet a fully commercial software. There are some known limitations and areas for further improvement. These have been documented as clearly as possible. The integrated tools have hundreds of possible inputs with almost limitless design permutations, so unfortunately it's not possible to test every one of these permutations. The tools will be released as open source software, so anyone can now contribute. Indeed, many project partners have plans for future development and use of the tools beyond the end of the DTOceanPlus project. This has a scope for both new functionalities and further testing and refinement of the existing code. Sorry, I meant to say the tools will be released on the 31st of August, hosted on the GitLab platform. See DTOceanPlus.eu website and social media for full details. So thank you for listening. If you have any questions, please ask them via the DTOceanPlus website or at the live Q&A session we have planned for the 31st of August. Thank you.